Dart School presents probability. Probability is the chance of something happening. It can be expressed as a fraction or a decimal or its equivalent percentage. As a fraction or a decimal, the probability of something happening or the chance of something happening is always greater than or equal to 0 and less than or equal to 1. As a percentage, the probability is always greater than or equal to 0% and less than or equal to 100%. When the chance of something happening is 0, we call that an impossible event. For example, if you are asked to pick an even number, the chance of picking an odd number is 0. And when the probability is 1 whole or 100%, we call that a certain event. It's sure to happen. You could say that probability of all human beings dying someday is 1 or 100%, and that's a certain event to happen. In maths, the probability of something happening is defined as the number of ways in which an event can happen divided by the total number of possibilities. Total number of possibilities. Imagine you are throwing a dice and you want to find out the probability that the number that shows up on the top is a multiple of, let's say, 3. Now, if you're throwing a dice has got 6 faces with the numbers 1 through 6 on its faces. So the multiples of 3 are 3 and 6. The number of ways in which it can happen is 2 ways. Either it could show up a 3 or it could show up a 6. Out of the total number of possibilities, of course, is 6. It can be any number from 1 through 6. So this is going to be 2 over 6 as a fraction, and that simplifies to 1/3. You could also find the probability of something happening by performing an experiment, and the probability in that case is given by something called relative frequency. Relative frequency, and that is given by number of times the event actually happens whereas in the mathematical formula you have the number of ways in which the event can happen. This is the number of times it actually happens divided by the total number of times the experiment was done. So if you were to find out the probability that a multiple of 3 shows up when you throw a dice using this formula, you would go on to record the outcomes. How many times it actually showed a 3 or a 6 out of the total number of times you throw the dice. And as you keep rolling the dice over and over again, this total number of times the experiment was done keeps going up. And when you do that a large number of times, you will see that this fraction out here that was recorded will be approaching closer and closer to this fraction 1/3 that's given by the formula. Let's look at a couple of problems now. A bag contains 3 red, 4 white, and 2 blue stickers. If you pick up a sticker without looking into the bag, what is the probability that the sticker you picked is not white? So the probability that the sticker is not white is given by the formula, the number of ways you could pick a sticker that is not white, that is 3 red and 2 blue, that's 5, out of the total number in which you can pick a sticker from this bag. So 3 plus 4 is 7 plus 2 is 9. So we have 9 on the bottom. So the probability that the sticker is not white is 5/9 or 5 nines. Let's do another one. If a number is chosen at random from 1 to 30, what is the probability that the chosen number is a multiple of 4? And the required probability is probability that the chosen number is a multiple of 4 is equal to, on the denominator we have 30 because you could pick the number in 30 different ways from 1 to 30. Out of them, what are the multiples of 4? So we have 4, 8, 12, 16, 20, 24 and 28. So we have 7 multiples of 4. So this is going to be 7/30. You didn't really have to count them, to be honest. You could tell yourself, okay, what's the closest multiple of 4 to 30 that doesn't go beyond 30? And that would give you this number 28. So you would say, okay, because 4 times 7 is 28, I have 7 multiples below 30. In any case, you still get 7/30, and this is the required probability.